Hey guys, this is Mrs. Lyons. I am going to go through a quick answer key for the review guide for the stoichiometry test. So we're just going to kind of work through this together, list the diatomic elements. Those you know are my friend Hober-Finkel: hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, and chlorine. Those are the diatomic elements. So that means that whenever you see them alone in an equation, there are two of them bonded together. All right. Next question. What type of reaction is this? This is a combustion reaction. We know that it's combustion because it's got this hydrocarbon combined with oxygen. All right. The states of matter, the reactants are both gases. And then carbon dioxide, this is a gas. This is a liquid. All right. Something else you'll see on the test, as you saw in the quiz, the coefficients are these numbers out in front. Okay. Subscripts are the smaller little numbers. I believe it does ask you that. And then really important, read the question on the test. The products are on the right side of the arrow. The reactants are on the left. All right. A visual model. Okay, so by a visual model, what we mean is you could do one of two things. You could just draw, you could draw shapes, or you could draw letters. So let me show you two things that would be acceptable. So let's say we've got carbon, hydrogen, and oxygen. So I'm going to say carbon is going to be a triangle, oxygen is going to be a circle, and hydrogen is going to be a diamond. Okay, so I have CH4, so that's one carbon and four hydrogen. I don't care how you connect them as long as all of the atoms in a molecule are connected. Okay, and then we've got two O2s. So an O2 would be two oxygens stuck together. We have two of those. Okay. And then we have one CO2, so that's a carbon connected to two oxygens. Okay. And we have two H2Os. So H2O is two diamonds. Okay. And an oxygen. But we have two of those. Okay. So this would be CH4 plus O2 is one CO2 plus two H2Os. That would be one way to represent it. Okay. Another way would be just to show the elements. Now the goal in this model is that there are no numbers. So I would do C, H, 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 that's CH4, plus O2, which is two oxygens connected. Okay. That produces a CO2, so COO, plus two H2O, so H, H, O, H, H, O. So basically all we want you to do in that little question is just kind of show us that you can count atoms and you can represent them, not written in their chemical formulas. Okay? All right, let's see. Balance the following equation. Okay, so first of all, this is a combustion reaction. The products of combustion are always carbon dioxide and water. They're both going to be gases. Okay, now if you look at this, I always say balance, start with your hydrogen, because there are 10 hydrogen here, there are 2 here, which means we should put a 5 here. However, 5 is an odd number, which would give us an odd number of oxygen. That doesn't work. So if you get a 5, or if you get an odd number in front of water, I want you to double it. So instead of 5, I'm going to go 10. Okay, so now I have 10 times 2 is 20 hydrogen. If I put a 2 over here, 2 times 10 is 20 hydrogen. And then I've got 2 times 4, I have 8 carbon. So I'm going to put an 8 here. Okay, I do have other videos that kind of go through this process more slowly. If you look at the useful videos link on the weekly preview, there's a set for combustion, synthesis, and decomposition if you're struggling with these. Okay, so I had 8 carbon, 8 carbon. So now I need to add up my oxygen. So I've got 8 times 2 is 16, and then 10. So I've got 26 oxygen divided by 2 is 13. Okay, so that is balancing that double or that combustion reaction. All right, now I'm going to write my mole map up here so that I can refer to it. You will get that on the test. Okay, now question, how many grams of C4H10 react if 6.15 moles? So our given is 6.15 moles of H2O. Make sure you read that. Don't get the wrong substance. And our unknown is going to be grams of C4H10. Okay, so if you look at your mole map, okay, we're starting, remember that our given substance is always A. Okay, so we're starting with moles of A. So I'm going to ignore grams of A in my mole map because I'm starting with moles of A. So I'm going to write H2O here. Okay, and I'm going to grams of B. So B is C4H10. Anywhere I have a B, it's going to be C4H10. Okay, so now I'm going to set up my problem. 6.15 moles of H2O over 1. Okay, moles of H2O is going to go on the bottom. Whatever, this is the thing you've got to understand. This unit and substance always comes down, so it will cancel out. Okay, so moles of H2O goes on the bottom. Now, look at what our mole map says. So we started with moles of A. That's right here. Next step is moles of B. So that's what we're looking for in step 1. So moles of C4H10. Okay, now, when you have moles of one substance over moles of another substance, that's the mole ratio. And that comes from your balanced chemical equation. So H2O is 10 and C4H10 is 2. So now I'm going to do that math. All right. So 6.15 times 2 divided by 10 is 1.23 moles of C4H10. Okay, so that's the answer to step 1. Okay, we're going to take that answer down here and use it in step 2. So 1.23 moles of C4H10 over 1. Remember, our units come down, so moles of C4H10 on the bottom. On the top, if I look at the last place, where am I going to end up with my mole map? Grams of B. So grams of C4H10. Okay, now I have moles and I have grams. This is where I use the molar mass. So 1 mole of C4H10 has a molar mass of, we have to look at our periodic tables. Okay, here we go. Here's my periodic table. So C4H10. So I've got 4 carbon, so 4 times 12.01, and then I have 10 oxygen. So 10 times 1.01. So let's see, I have 48.04 plus 10.10 gives me a molar mass of 58.14. So that's what's going to go here. 58.14 grams of C4H10 is the molar mass, is equal to 1 mole. Remember, our units cancel. I didn't cancel my units up here, but we should always make sure our units cancel. All right, I'm going to do 1.23 times 58.14. I'm going to get 71.51. That is my answer. Grams of C4H10. Okay. All right. Question number 7. So this says we are given 0.95 moles of CO2. And we want to know how many moles of O2. Okay, so if you are looking at your mole map, let me write it out here again. Okay, grams of A, moles of A, moles of B, grams of B. We're starting with moles of A. So we're starting here. So we don't need to worry about this. And we're ending at moles of B. So we don't need to worry about this. All right, so we're starting with moles of CO2, ending with moles of O2. Okay, so I'm going to write my given 0.95 moles of carbon dioxide. O is over 1. All right, units, moles of carbon dioxide come down so they cancel out. On the top is what I'm looking for, so moles of O2. I have moles of one thing over moles of another thing. That's where I look for the coefficients up here. So moles of O2 is 13. Moles of CO2 is 8. My units cancel. I'm going to do that math. I do 0.95 times 13 divided by 8 is 1.54 moles of O2. Okay. All right. If 4.25 grams of oxygen react, how many grams of water are produced? So this one, we should be able to look at this one and say, yeah, this is a grams to grams problem. So let me move another piece of scratch paper. There we go. All right, so we are given 4.25 grams of oxygen. We're looking for grams of H2O. So let me write my equation up here again. 2C4H10 plus 13O2 produces 8 carbon dioxide and 10 water. Okay. So, and I'm going to write my mole map here. So I've got grams of A, moles of A, moles of B, grams of B. Okay, whoops, I forgot my B. Okay, now I'm going to fill in. Okay, I'm going to fill in. A, my given A is O2. So I have grams of O2, moles of O2. Then I have moles of B, so I've got moles of water and grams of water. Okay, so I'm going to go all the way across the mole map. So I'm going to start with, 4.25 grams of O2 over 1. Grams of O2 is going to go on the bottom. And then, okay, so I'm going grams. Next is moles of A. So moles of A, moles of O2 goes on the top. When I have grams and moles, I'm going to use my molar mass. So 1 mole is equal to the molar mass on the periodic table of oxygen. Oxygen is 16. We've got 2 of them. So that's 32. Notice my grams of oxygen cancel out. And I'm going to do 4.25 divided by 32.13. And I'm going to carry just a couple of digits because, you know, as Mr. Allen says, YOLO, you only round once. So I'll round when I get to my final answer. So this is moles of oxygen. Okay, so now that was step 1. Step 2, I want to go from moles of oxygen to moles of water. Okay, so 0.1328 moles of oxygen. So moles of oxygen goes on the bottom. Okay, and then what we're looking for goes on top. So moles of H2O. All right, so I have 13 moles. Remember when I have moles of one thing and moles of another thing together in my conversion, I have to use the mole ratio from the balanced chemical equation. So 13 moles of oxygen and 10 moles of water. My units cancel. Okay, so times 10 divided by 13. 0.1022. Let's do 0.1022. That's moles of water. That's step 2. Last step. I've got moles of water. Now I need to go to grams of water. So 0.1022 moles of water. Moles of water comes down, so it cancels out. I'm looking for grams of water. So grams of water is going to go on the top. Okay. This is where we use the molar mass. So 1 mole is equal to the molar mass of water. We know, remember, oxygen is 16. Hydrogen is 1.01. We've got 2 of them. Whoops. That gives us 18.02 as a molar mass. Units cancel. All right, and we're going to times 0.18.02, 1.84, and this is our final answer, so we will round 1.84 grams of water is our answer, 1.84 grams of water. All right, one more on this page. Let's see. So, if 10 point, let's slide this up. All right, so we are given 10.67 grams of C4H10. We're looking for moles of CO2. All right, if I do my mole map, I've got grams of A, moles of A, moles of B, grams of B. Okay, if I look, I'm starting with grams of A. So I'm starting here. I'm ending, though, at moles of CO2. So I don't need to go all the way to grams. I'm going to end at moles of B. All right, so my A is C4H10. And my B is CO2. I need to write my equation, my balanced equation up here again. C4H10 plus 13O2 produces 8 CO2 plus 10 H2O. Okay, so I start with 10.67 grams of C4H10. Okay, I'm going to bring these units down. So grams of C4H10. Okay, that's this. I want to find moles of A. So moles of C4H10. So this is where we use the molar mass. So 1 mole of C4H10 has a mass of, didn't we just figure that out up here somewhere? Let's see. Yeah, we did. 58.14. Remember, we calculated that a minute ago. So I'm going to save myself time. 58.14 grams. All right, my units cancel out. So let's see, I have 10.67 divided by 58.14, 0.1835 moles of C4H10. That was step 1. Now I need step 2 to go from moles of A to moles of B. So I start with 1835 moles of C4H10. So moles goes on the bottom. And then what we're looking for, moles of B, so moles of CO2 go on the top. All right. And here we need to use the coefficients from our balanced chemical equation. So 2 moles of C4H10 is going to give us 8 moles of carbon dioxide. So I'm going to take my number times 8 divided by 2. And this is my final answer, so I'm going to round that to 0.73 moles of CO2. Okay, so let's write this here, 0.73 moles of CO2. All right. Oh, let's see, gallium nitride. So we need to write the products of this decomposition reaction. So this is an ionic compound, so it's a solid. It's going to break down to give me gallium, which is a metal, so a solid, plus nitrogen. Nitrogen is one of our 7 diatomic elements. So our balanced equation is going to look like this. All right. So how many grams of gallium is produced? So our given is 15 moles of gallium nitride. And we're looking for grams of gallium. Okay. I'm going to write my mole map up here. Grams of A, moles of A, moles of B, grams of B. So if you look, we're starting with moles of gallium nitride, and we're finding grams of gallium. Okay, so B is gallium. So let's start this out. 15 moles of gallium nitride. Okay. Moles of gallium nitride is going to go on the bottom. Okay, so that's where we're starting, moles. We want to go to moles of B in our first step, so moles of gallium. Okay, moles and moles, this is where we use our coefficients. So 2 moles of gallium nitride produces 2 moles of gallium. Our units will cancel out, and that will give us 15 moles of gallium. All right. So that is step 1. Step 2 is going to go from moles of B to grams of B. So we're going to start with 15 moles of gallium. We want moles of gallium on the bottom, so it cancels out. And we're going to find we're going to find grams of gallium. So grams of gallium. So this is our molar mass. So 1 mole is equal to, 1 mole is equal to, gallium is 69.72 grams. 69.72 grams. 15 times 69.72. Is that right? I got to check that math again. 15 times 69.72 is 1,045.8 grams of gallium. Remember, we want our units to cancel out. Okay. So that's going to be 1,045 grams of gallium. All right. Second question on this problem. So we are given, our given is always going to be that thing with the number in it. So our given is 210 grams of gallium. And we want to know how many moles of nitrogen gas. Okay. Okay. So in this case, gallium is A. So I'm going to write this in on my map. Gallium is A and nitrogen is B. Okay. So now I'm starting with grams of A and ending with moles of B. So I don't need that last step. This is going to be a two-step problem. So 210 grams of gallium. Grams of gallium is going to go on the bottom. Okay. Moles of gallium, that's our first step. That's what we're looking for. Moles of gallium is going to go on the top. This is where we're going to use our molar mass. 1 mole is equal to, what did we say, 69.72 grams of gallium. So step 1, I'm going to take 210 divided by 69.72. I'm going to do 3.012. 3.012 moles of gallium. Okay, so that gets me to right here. Now I need to get to step 2, which is to go to moles of B or moles of nitrogen. So I have 3.012 moles. See how important these units are. These units are so important. If I would have written grams there, I would have put grams down here, which would have made me think I needed the molar mass. So the units are so important. Okay, so moles of gallium on the bottom. And then moles of B, moles of N2 on the top. This is where we use our balanced chemical equation. So 2 moles of gallium and 1 mole of nitrogen. I'm going to divide that. 1.5, we're going to go 1.51. Our units cancel, leaving us with moles of N2. 1.51 moles. Okay. What do we got next? How many moles of gallium nitride are required when producing 2.82? So our given is 2.82 moles of gallium. What we're looking for is moles of gallium nitride. This one is sweet because, check it out, this is one of our only one-step problems. So we're starting with moles of A, we're going to moles of B. A is gallium, B is gallium nitride. Okay, so 2.82 moles of gallium over 1. Moles of gallium is going to go on the bottom. Again, that is key to getting these problems set up right, guys. Whatever this unit is has to come down here. So moles of gallium on the bottom, moles of gallium nitride on the top. All right, this is where we need to look at our balanced chemical equation. So 2 moles of gallium nitride is 2 moles of gallium. All Our moles of gallium cancel out. Our answer is 2.82 moles of gallium nitride. Okay. What do we got here? All right. Oop, my paper's always crooked. If 39 grams, so our given is 39 grams of gallium nitride, is used, how many grams of nitrogen is produced? Okay, so gallium nitride is A, nitrogen is B. Okay, so let's put our mole map up here. All right, so A is gallium nitride. So anywhere I have an A in my mole map, I need to write gallium nitride. Anywhere I have a B, I need to write N2. Okay, so I am going to start with 39 grams of gallium nitride. So this is a three-step problem. We need to go all the way from grams of A to grams of B. Okay. So bottom, we have grams of gallium nitride. On the top, we have moles of A. Okay, so let's see. Gallium nitride. So gallium, I got to add this together. Gallium is 69.72 and nitrogen is 14.01. So the molar mass is 83.73. What that means is there are 83.73 grams of gallium nitride in 1 mole of gallium nitride. Okay, our units cancel out. So we're going to do 39 divided by 83.73. And we get 0.4, we're going to go with 0.4658. Because we've got more steps to go. That's moles of gallium nitride. Okay, so I'm going to bring that down, 0.4658 moles of gallium nitride over 1. Okay, we want moles of gallium nitride on the bottom. On the top, okay, so we've moles of A. On the top, we want moles of B, so moles of N2. Okay, this is where we use our balanced chemical equation. So moles of gallium nitride is 2, and moles of nitrogen is 1. Okay, moles of gallium nitride cancel out. If I do that math, I get 0.2329 moles of N2. All right, so that gets me to right here in my mole map. So now I need to go from moles of N2 to grams of N2. All right, so 0.2329 moles of N2. All right, moles of N2 is going to go on the bottom. Grams of N2 is going to go on the top. All right. This is where we use the molar mass. So 1 mole of nitrogen. Remember, nitrogen's molar mass is 14.01, but we have 2. So that's going to be 28.02 grams. Moles will cancel out. Times 28.02. 6.53 grams of nitrogen. All right, so our answer is 6.53 grams of N2. I'm real quick going to write and balance this equation. I may come back in a little bit and make a video for this. If not, you're going to use the exact same process we've used on the previous 2 pages. But the reaction is a combustion reaction, which produces carbon dioxide gas plus water gas or water vapor. These are all gases. And this one balances relatively easy. All right, guys, I will get this posted, and hopefully it will be helpful to you in reviewing for the test. Take care of yourselves, and I will see you in class.